Hey everyone, in this video we are going to solve the 3-sum problem on Leetcode. It will be similar to the 2-sum problem. So we are given an integer array and we have to return all the triplets, all the values, all the triplets which when add together results 0. And the solution must not contain any duplicates. So this is the question. Let's see how we can do it. So to solve this question, we can use the same approach, one of the approach that we use to solve the 2-sum problem. The solution that may come to our mind is to use 3 for loops. So we'll keep running 3 for loops and keep finding the triplets that result to 0 and adding them to a result array. And that will be an O of n cube solution, which is not a very optimal solution. And another way another more optimal solution could be first to sort this array. So if we sort this array, it will become -4, -1, -1, 0, 1, and 2. Next, we can divide this problem. So let's say if we have three numbers, so any three numbers which when add up results 0. So let's say we start from -4. I is at -4. Our loop start from first element. So first element is -4. We consider our first number is -4. The remaining part of the problem remains that we need to find two such numbers which when added with -4 results 0. So it become a two-sum problem. So we got -4 and in the remaining part of the array we have to find such numbers which when added with -4 result 0. Or even better, what we can do, if we move 4 here, if we move 4 to this side, the question will become to find any two numbers which when add together results 4. Okay, so it will become a two-sum problem. So first we got our first number, that is -4, and we move it to the right side. We multiply it by -1, or we create we reverse the sign, and the remaining part of the problem becomes to find two such numbers, a two-sum problem, to find two such numbers which when add together results 4. So let's dry run this approach. So our first number is -4, and in the remaining part of array we'll have two pointers, and left pointer and a right pointer. And right now, as you can clearly see, in this remaining part of our array there are no such numbers which when add together results to 4. So we can just skip this iteration for the dry run only. And next, our next number will be -1. So next number is -1. So if we move it to this side, the question will become to find two such numbers which when add together results 1 in this remaining part of the array. So let's say we start with the two pointers. So left pointer and right pointer. And if we add them together, will it result 1, positive 1? Yes, it will. So we have found our first triplet here. So if we add -1 and 2, it results 1. So our first result, so in our result array we'll have a result array, and in that we'll add this first triplet. So our number I and our number present are at left and right pointers. So -1, -1, and 2, this is our first triplet that we have found. Now you see that these two numbers, -1 and -1, they are both similar, and it may cause us to have duplicates as well. So let's say if we when we got to this position at -1, and in the remaining part of array we have another -1 and 2, so adding them together also results to 1. So in that case it will cause us to have duplicacy in our result, and the question strictly says that we should not have any duplicate triplets. So what we can do, when we know that there are duplicates, uh, two adjacent elements are equal to each other, so what we can do, we can just skip them or move the left pointer one step more forward. So left pointer will move from -1 to 0, And since we have found our result, so we need to update our right pointer as well. So a right pointer will also update to 1. So next we have -1, 0 and 1. So we have -1, 0 and 1. So does adding 0 and 1 results 1? So similarly, as we add previous two numbers were -1 and 2, adding them result 1, and these two numbers 0 and 1, adding them together does results 1. So another triplet that we have found is -1, Ri, and L and R. So L is 0 and R is 1. Sorry, L is 0 and R is 1. Next, we'll again, we don't have anything, so we'll move one step forward. In the next iteration, I will come here and L and R will be here. And in the remaining part of the array, we don't have any chance of finding any triplets. So we'll just skip this one for the try run. And at the end, this will be our output, which will be returning. The time complexity for this one will be O of n square, and space complexity for this one will be O of n, as we are also storing the result, and also some sorting algorithms also take some amount of space. So in the worst case, we can consider that this will be O of n. This is the drawing explanation. Let's see how we can do it in code. So first, let's sort our array. So we have to sort it in ascending order, and since in JavaScript sort doesn't work just by writing nums dot sort, since by default JavaScript considers all numbers as all inputs as strings, and it sorts the array as if the array consists of strings instead of a number. So to sort it, we'll write a comma b, and that will pass a minus b to sort it in ascending order. Next, we'll have our answer or result array, in which we'll store our final output and we'll be returning this. Next, we'll run a for loop. We'll start from I equals to 0, I is less than nums dot length, and I plus plus. So about the duplicate, so we need to make sure if I is equals to 0, or num set I minus 1 is not equal to num set I. So we are not at the first index, we are not at the 0th index, and the two adjacent elements are not same to equal to each other, because if they are, we'll just move one step forward. We'll skip that part. We'll skip that number. Next, let's declare our left and right pointer. So let left equals to I plus 1, and let right equals to nums dot length minus 1. So while left is less than right, so we got our first number, the I number, the number at index I. We got our second number, 2 pointers left and right, and we need to find two such numbers which, when add together, results to minus of num set I. So what do I mean by that? If nums at left plus nums at right, adding these two numbers, it results to minus of num set I. Why? Because remember, we'll be moving the number at ith node to the other side, and it will multiply it by -1, or it will change its sign. So if this condition is true, if adding these two numbers results to minus of nums at I, we'll just push this triplet to our answer array. It will be num set I, num set left, and num set right. That we'll need to update our left pointer. So left plus plus. After that, we need to check for duplicacy. If the new number at left pointer is equal to the previous number, we need to move even one step forward. That minus one comma minus one situation, because otherwise it will create duplicacy in our answer. So for that, we'll write while left is less than right and num set left minus 1 is equals to num set left. If this condition happens, if two adjacent numbers are same again, the next two numbers, then again we need to move left pointer one more step forward to avoid duplicacy in our code. We have found a match, we have found a triplet. We need to reduce the right pointer as well. So right minus minus. And same again for the right pointer. So while right is greater than minus 1 and num set right, sorry, num set right is equals to num set right plus 1. In that case, we need to reduce the right pointer one more time. So right minus minus. Else, so if we didn't found a match, so we need to check if we need to move the right pointer or the left pointer. So else if num set left plus num set right, if it is less than minus of nums at I, we need to move the left pointer one step forward. Else, that means the result that we get is greater than minus of num set I. In that case, we need to move the right pointer one step backward. And this is the and outside this for loop will return the answer array. So this is the code. Let's run this. It's working. Let's submit it. Cool. So that was it for this video. Thank you for watching.